we need to write a double list that doubles the size of our list by appending a copy of our original sequence to the end of our list. So for example, if we had something like this, it would just be doubled. We're not reversing the order, it has to be in the same order, has to be. Now, there's more parameters right here. You can read through them if you want. You can also assume that this class exists, so we're just going to be adding into it. Let's code this. It's going to be a public void, and then it's called double list. We are taking no parameters, and we're just keeping it as void because we're not returning anything, only modifying. So how are we going to do this? How are we going to do it? Well, first, one of the parameters that we have to check is if our list is not null. If it is, we're not going to want to operate on it. But if it is not null, then we want to operate on it. So if this dot front is not equal to null, we are going to be inside of here. You can also, for future check, because it will still pass the test, but you should also put this dot front dot next is not equal to null, because if we just have one value, then we don't really need to run through this because, well, there's no point, right? Because if the first one has a value, but there's no value in the second one, there's nothing you need to rearrange. So being good programmers, having parameters in place, we'll do this dot front dot next does not equal to null. As long as these two conditions exist, we can be inside of here. This means that it has to have more than one element. So to do something like this, I am going to have a counter, and this counter, essentially what it's going to do is going to be what adds these in the back. So let's do an int counter is equal to 0, and then from here we want to go through this entire list until we're at the very end, and then we could add to the back. So that's what this while loop is going to be doing. Let's first make a new list node and call it current and set it equal to this dot front. That's going to grab the front, and then we can run through it here. Well, current, and we can do dot next because we want to be like the 7 right here. The next one would be null. We don't want to move our current pointer to that null value. We want to keep it at 7. That way, when we put all these values back in here, we can use current.next. We don't just have some null value in the middle. So while current.next is not equal to null, we're just going to say current is equal to current.next. So we're just moving our pointer down our list. So that's going to do that for that while loop. After we do that, that is there now is where we need to add our duplicate values. So we're at the very end of our list. We can now add things in. We're going to make a new list for that. So let's do list node, and I'm going to call this append. This is what we're appending to the end, and it's going to be equal to this dot front. That's pretty much it. We can't just add it directly because we might get like a circular reference, basically where it continues to loop. If we add it because how we're putting the front at the end, and it needs to have a null at the very end, if that makes sense. You could try it and you'll get an error. As a matter of fact, you know what? Let's try it. So we're at the end already, right? Our next one is null. So that's for our current, right? So what we could do instead of this is just say current is equal to, or I'm sorry, current.next. Current.next, which is the null value, right? It's currently pointing to null. We're going to overwrite it, and we're just going to have it be this whole front part, right? So current.next is equal to this dot front. If we are to submit this, I'm telling you, you're going to get a circular reference error. So while that runs, we'll just delete this, and you see it cycles right here. It's just going to keep going and reading itself over and over again because it's just continuously going to be appending the front, which is not what we want to do. So with this list node here, which is fine, that's great, we want to run this while our counter is, it has to be greater than 0, right? So counter should be incrementing. Where should it be incrementing? In this while loop. So let's actually put braces here because we're going to have multiple lines. Do counter plus plus, and this is essentially saying that every single time we move through here, we're going to have another value added. So it starts at 0, right? Counter's right here, and then we are going to add one value when it moves. So 1 value, 2 value, 3 value. So we should have 3 values for this. That's going to be 0, 1, 2, 3. For this while loop, we'll run this while our counter, and we'll do minus minus because every time afterwards we run this, we want to subtract 1 from it. That way we can eventually decrement it all the way down to less than or equal 0. So while counter is greater than or equal to 0, we're going to be inside of here. And inside of here is we're going to do our appending. So we're going to set our current dot next. So this is the pointer to the next value, equal to a new list node where we are going to have our append dot data. New list node, like let's say after 7, is going to now be append dot data. That's pretty much going to be it. And then the null pointer is going to be after that. So we have to move this the reference, the current pointer, from here to the next one. And doing that, we'll do current is equal to current dot next. That moves it down one. And then we also have to move through our append list. So we're going to do append is equal to append dot next. That way we can go through the entire list, close off this while loop, and eventually we'll hit the null value. Let's press submit. If you have any questions on this, leave them in the comments below. That'll pass forward for tests, and if you want more practice it, as always, it's in that description below the like button. That'll be it for exercise 16.18 double list.